Welcome students to standard 11th. We are going to study subject physics. Yesterday we had completed session 1. Now moving to session 2. We are continuing with the chapter same, that is chapter number 2, units and measurement. The very first topic over here is advantages of SI system. Yesterday we have studied what is SI system. There are 7 basic fundamental quantities: length, mass, time, temperature, amount of substance, luminous intensity and electric current. These are the basic 7 quantities that we have studied yesterday. Now move to the advantages of SI system. The very first topic is advantages of SI system. The very first point in the advantages of SI system is SI is a coherent system of units. Coherent system of units. Now what do you mean by the coherent means? Means all the derived units in this system are just either multiplication or division of two physical units. There is no numerical factor included in it. We can write that all derived units are obtained by simple multiplication or division of fundamental units without introducing any numerical factor. Clear? I can give you an example over here. Example, we have a derived quantity known as density. Yes or no? Density is equal to what? Mass upon volume. For the case of density unit, we know that the density unit is kg per meter cube in SI, right? So mass unit is what? Kg. Volume unit is what? Meter cube. Is simply division of what? Two quantities. Kg is one quantity and meter cube is second unit. Yes or no? So it's division of two fundamental units, that is mass and length, that is kg by meter cube. That is nothing but SI unit for density. The second point over here is SI is a rational system of unit. SI is a rational system of units. Rational means what? It uses only one unit for given physical quantity. Example I can give, there are n number of types of energy you will able to come into day-to-day life, that like mechanical energy, electrical energy, thermal energy, heat energy, electrical energy. These all energies are what? In case of why it is said to be a rational system? Because for all energies the unit is common, that is joule only. That is joule only in case of SI system. But in MK system you will able to see that various energies have various units. I can give you an example. Electrical energy is used to measure in watt hour, that we have studied in standard 10 chapter for electricity. Then calorie, that energy, heat energy is measured in calorie. Then mechanical energy is measured in joule. So for different energy they are having different units in MK system, but in case of SI system they have only one common unit for all types of energy. Yes or no? So I can write that it uses only one unit for a given physical quantity. In MK system you are having different units for different types of energy. Mechanical energy you are measuring into what? Joule. Electrical energy you are measuring in watt hour. Yes or no? Watt hour. Heat energy you are measuring in what? Calorie. So there are various units in MK system, but in SI system all forms of energy are measured in 1 unit, that is joule. Clear? The third point, that is the third advantage of SI system, is SI system is a metric system. SI is a metric system. What do you mean by metric? That can be expressed in powers of 10. That can be expressed in powers of 10. The multiples and submultiples of SI units can be expressed as powers of 10. You can express in powers of 10. That's why it is known as metric system. SI is an next advantage. SI is an absolute system of units. Absolute system of units. So what do you mean by absolute system of units? It does not use gravitational units. It does not use gravitational units. The use of small g, that is what, acceleration due to gravity, is not required. The last advantage, SI is an internationally accepted system of unit. Internationally accepted system of units. Hope it is cleared, all 5 advantages. Now moving to the next topic, that is guidelines for writing SI units in symbols. SI units in symbols. Now how to write symbols in SI unit? We have seen length is written as meter small m, then mass kg, kilogram, kg, that we have seen all 7 quantities and their symbols also. Now how to write symbols in SI unit? The very first point you have to keep in mind, that is always small letters are used for symbols of units. Clear? Always you have to use small letters. Second, symbols are not followed by a full stop. There is no full stop after symbols. Remember, third point, the initial letter of a symbol is capital only when the initial letter of symbol is capital only when they have mentioned the unit is named after a scientist. I can recall you actually, and I can give you the example for the same. Yesterday you have written a quantity known as electric current. Yes or no? The scientist was Ampere, and you mentioned the symbol capital. If the symbol has initial letter capital, if the unit is named after scientist, this should be always small a. Remember, if you are writing the symbol or you are writing the unit in words, remember your letter should start in all small letters only. So A should be small. Second, you have written thermodynamic temperature. If you remember, thermodynamic temperature, that was named after a scientist which? Kelvin. Yes or no? So your symbol was what? Capital K. Till this clear? Hope it is clear to all. Now moving to the next, that is third, that is very third point that we have discussed right now, that the initial letter of the symbol is capital only if the scientist, if the name of the symbol is name of the unit is after the scientist. Now the next point is the full name of a unit. The full name of the unit is always begins with a small letter, even if it's after the name of scientist. Name of scientist. I just now give you the example. That is, if the quantity is electric current. If the quantity is electric current, the unit of electric current is named after scientist what? Ampere. The starting letter should be always small and the symbol is always capital, that is A. Next is what? Thermodynamic temperature. For the case of thermodynamic temperature, the unit is named after scientist Kelvin. Remember, this K is small and symbol is capital K. Till this clear? The last point, that is fifth point, symbols do not take plural form. Symbols do not take plural form. Clear or not? Don't take plural forms of the units. Fine. Moving to the next, that is abbreviations. Next topic, that is abbreviations in powers of 10. I want to tell you what are the abbreviations in power of 10 that you have to study over here. These are the abbreviations of power of 10. How do you to remember? See, there is a power of 10, there is multiple prefix symbol, there is submultiple prefix and symbol. Now first you have to see deca, hecto, kilo, mega, giga, tera, peta, exa. Here you will be able to see deci, centi, milli, micro, nano, pico, femto, and last is atto. Now how you will remember the pair, that is exa, atto, peta, femto, tera, pico, giga, nano, mega, micro, kilo, milli, hecto, centi, deca, deci. You will note down over here, that is there is 10 power 1, 2, 3. After 3 you are having 3 multiples of 3. 3 2s are 6, then again 3, 9, 9 plus 3, 12, 12 plus 3, 15, 15 plus 3, 18. Here all the multiples are in positive powers of 10. Here you will be able to notice that all the multiples, sub-multiples are in negative powers of 10. 10 power minus 1, minus 2, this is plus 1, this is minus 1, plus 2, minus 2, plus 3, minus 3, plus 6, minus 6, plus 9, minus 9, plus 12, minus 12, plus 15, minus 15, plus 18, minus 18. The symbol for deca is DA, hecto small h, kilo K, mega capital M, giga capital G, tera capital T, peta capital P, exa capital E. Remember these three are small, that is deca, h, k. Here deci small, all are small in the case of what? Submultiple, that is deci small d, centi small c, milli small m, micro mu. This is a new Greek letter, that is mu, nano n, pico f, femto f, and atto a. Clear? Once again I recall the sequence, that is exa, atto, peta, femto, tera, pico, giga, nano, mega, micro, kilo, milli, hecto, centi, deca, deci. 10 power 1, 2, 3, plus 3, 6, 6 plus 3, 9, 9 plus 3, 12, 12 plus 3, 15, 15 plus 3, 18. Similarly you take minus 10 power 1, 10 power minus 1, minus 2, minus 3, minus 6, minus 9, minus 12, minus 15, minus 18. Clear? Let's take some example for this. The very first example I can give you, that is 1 mega ohm. That is how many ohms? Mega means 10 power 6. Similarly, if somebody asks you the question of 1, same to, that is 1 micro ohm. So what you will write? 10 power minus 6 ohm, mega plus 6, micro minus 6. Similarly, one can give you the example of what? 1 kilometer. 1 kilometer is how many meters? 10 power 3 meters. Yes or no? If one asks 1 millimeter, then 10 power minus 3 meters. Hope it is clear. If somebody asks 1 picofarad, then it is 10 power minus 12 farad. Pico is always 10 power minus 12. Till this clear? Hope it is clear. Now moving to the next topic, that is some practical units. Some practical units that we are going to study today. Clear? The very first practical unit, that is Fermi. Where it is used, sir? Fermi is always used for the small distance measurement in nuclear sizes. It is mainly used in to measure nuclear sizes of the atoms, sizes of the molecules is always measured in Fermi. So first Fermi, I'll write definition. It is small practical unit of distance used for measuring nuclear sizes. It is also called femtometer. Fermi is also known as femtometer. You can say femto. 1 Fermi, it is equal to 10 power minus 15 meters. Remember, 1 Fermi 10 power minus 15 meters. I can give you one note over here, that is general knowledge. The radius of a proton is 1.2 Fermi meter. 1.2 Fermi. Radius of proton is 1.2 Fermi. Now moving to the next. Okay, now the next, that is Armstrong. Armstrong, it is used to express wavelength of light. Remember, 1 Armstrong denoted by symbol like this, 1 Armstrong, that is equal to 10 power minus 10 meters. How much? 10 power minus 10 meter. If I want to convert meter into centimeter, 1 meter is how many centimeter? 10 power 2, that is 100. Now 10 power minus 10 plus 2, minus 10 plus 2 leads to how much? 10 power minus 8 centimeter. Till this clear? Third is nanometer. That is, everybody knows, it is also used for expressing wavelength of light. One nanometer, that is equal to 10 power minus 9 meter. Next is micron. It is unit of distance. Defined as micrometer. 1 micrometer, you can say 1 micron. Plastics are measured in micron, you know. 10 power minus 6 meter. Thickness of plastics, micron. Fifth, that is light year. Very important. What is light year? It is the distance traveled by light. In 1 year. How much distance is traveled by light in 1 year in vacuum is called 1 light year. Now let us calculate 1 light year. 1 light year, that is equal to speed of light in vacuum into you're having 1 year. Now speed of light in vacuum, that is CA, that everybody's know. How much? 3 into 10 power 8 meter per second. If I want to convert this 1 year into seconds, How I'm going to convert 365 days, but I'm using 365.25. How much, sir? 365.25. In every 4 hours there is one leap year, yes or no? So I can say 365 plus 365 plus 365 plus 366, that is one leap year. Divide by 4. If I'll calculate this average, let us calculate the average. 365 plus 365 plus 365 plus 366 by 4. I can get 365.25. So if I'm taking average, I'm taking the average of 4 years, in which I'll get one as leap year and one more day, that is 365 plus 1, that is 366. That's why I'm using number of days in 1 year, that is to be 365.25 into 1 year. 1 year, this many 365.25 days. 1 day is 24 hours, 1 hour 60 minutes and 1 minute 60 seconds. This much is my answer. If I'll multiply this, therefore 1 light year, that is equal to 3 into 10 power 8, that is speed of light, into 365.25 into 24 into 60 into 60. That is, first I'll multiply 3 into 365.25, 24, 60, 60. I'm going to get 94672 into 10 power 8. 1, 2, 3, 4, 5, 6, 7. 9.467 into 10 power 8 into 10 power 7. Remember, if you are moving this side, you have to take plus powers of 10. If you are moving towards left, you have to take plus. If you are moving towards the right, then you have to take minus. If you are moving your decimal place towards left, then you have to take plus positions. If you are moving towards right, then you have to take minus. I am moving towards left. 1, 2, 3, 4, 5, 6, 7. 3, 3, 6 and 1, 7. So I'll put 10 power 7. Therefore 9.467 into 10. If both base are same, powers are added. So I can get 9.467 into 10 power 7 plus 8 is how much? 15 meters. Hope it is cleared. Moving to the next. Next is now some few important facts about light years. Light year is used in astronomy to measure distances of nearby stars. If you want to measure the distance of the stars, we can use the unit light year. It is very large unit of what distance. Next is astronomical unit. Astronomical unit denoted by AU. Sorry, 1 AU, that is equal to 1.496 into 10 power 11 meter. Clear? It is defined as the mean distance of the earth from the sun. Clear? Next is parsec. Very important. Parsec is also known as parallactic second. Very first point about parsec is it is the largest practical unit of distance used in astronomy. Clear? Now it is defined as the distance at which an arc of length 1 astronomical unit, subtends an angle of 1 second of arc. I can tell you very simple way. The angle subtended by an arc length of 1 astronomical unit at the center is 1 second. Then this distance is known as 1 parsec. Clear? An arc length of 1 astronomical unit subtends an angle of 1 second at the center. The distance is known as what? 1 parsec. Clear? Now remember one thing. For minute there is 1 dash on the top. For second it is 1 double dash like this. For second you are having 2, and for minute you are having 1, and for degree you are having 1 degree like this. Clear? I want to tell you the conversion of one important thing over here, that is conversion of degree into radian. Degree into radian. If you want to convert degree into radian, denoted by symbol R on the top sometimes, and degree you are having the symbol like this, x raised to 0. This radian is x raised to R. Clear? If you are moving from degree to radian, you have to multiply your degree value into pi by 180. You have to multiply your degree value into pi by, suppose if I say convert 60 degree into radian, so what you will do? 60 into pi by 180, 0 0 cut, 6 3s are, so your answer is what? Pi by 3 radian. So you can write pi by 3 like this. Clear? Suppose if you want to convert vice versa, that is radian to degree. If you want to convert radian to degree, means x radian you have to convert into x degree. So radian into 180 by pi you have to multiply. What you have to multiply? 180 by pi. Clear? If I want to convert pi by 3 into degree, so pi by 3 by 180 by pi cut, the answer is how much? 60 degree. Hope it is clear. Degree to radian multiply by pi by 180, radian to degree multiply by reverse, that is reciprocal of this, that is 180 by pi. So we were talking about parsec. Now what is parsec exactly? The distance at which an arc of 1 astronomical unit subtends an angle of 1 second. Such distance is known as what? Parsec. This distance is known as 1 parsec. So now let us the value for calculation. Let us calculate the value of parsec in meters, then in light years. Now we know that arc length L, that is equal to angle theta into radius, that we have already studied in standard 9th, 10th maths. Therefore angle theta, that is equal to arc length L, this radius will move down, radius R. Fine. What is arc length? We have to calculate parsec. Parsec means we have to calculate this radius distance. Therefore radius, or you can say 1 parsec, that is equal to arc length L divided by angle theta. I can write that 1 parsec L by theta, arc length is 1 astronomical unit, divided by angle theta. 1 astronomical unit 1.496. Previously I told you that 10 power 11 meters, divided by theta is 1 second. Yes or no? It is 1 second, but this 1 second is not allowed. We have to convert it into 1 radian. Yes or no? Now remember, 1 degree, 1 second. I can convert this 1 second into radian, that is 1 divided by 3600 into pi by 180. Clear? 1 degree 60 minutes, 1 minute 60 seconds. So 1 degree is equal to 60 into 60 seconds. That is how much? 3600 seconds. If I want 1 second, I have to remove this by denominator. That is how many degree? 1 divided by 3600 degree. So degree into radian. If I have to convert degree into radian, I have to multiply by how much? Pi by 180. So instead of this, I can write 1.496 into 10 power 11 divided by 1 upon 3600 into pi by 180. Till this clear? What I will get? 1.496 into 3600 into 180 into 10 power 11 divided by pi, that is 3.142. Yes or no? Now calculate over here. 1.496 into 3600 into 180 divided by 3.142. That is how much? 3.308532.14 into 10 power 11. I am shifting towards my left. 1, 2, 3, 4, 5. So 3.08532 into 10 power 11 plus 5. Yes or no? I told you that if you are moving towards left, then you have to plus it. So 11.5, 3.08532 into 10 power 16 meters, I can say. More profoundly, I can write 3.08 into 10 power 16 meters. Clear? Therefore 1 per sec, that is, remember always, 3.08 into 10 power 16 meters. Hope it is cleared. Now moving ahead with the next few units that we are practically using. The next unit, that is barn. It is used for very small areas such as nuclear cross sections. Nuclear cross sections. Remember the conversion. 1 barn, that is equal to 10 power minus 28 meters square. 1 barn is how much? 10 power minus 28 meters square. Remember this, all the specific conversion, because these are going to ask in the assignment as homework. Next is acre, that we generally use. It is used in measuring large areas. In measuring large areas, 1 acre, that is equal to 4047 meters square. 1 acre 4047 meters square. Next is hectare. It is used for measuring large areas. 1 hectare equals to 10 power 4 meters square. How much? 10 power 4 meters square. Next, 1 ton or 1 metric ton, that is equal to, remember, 1000 kg. 1 quintal, 100 kg. Quintal is used for the measuring of weight of wheats and cereal pulses. 1 slug, 14.57 kg. 1 pound, also known as 1 lb, 0.4536 kg. Pound is used for measuring infant fetus, weight of fetus. First Chandrasekhar limit, 1 Chandrasekhar limit. 1 Chandrasekhar limit, sometimes used as 1 CSL, that is equal to 1.4 times 1.4 times the mass of the sun, 1 Chandrasekhar limit, 1.4 times the mass of the sun. CSL, Chandrasekhar limit, is the largest practical unit, the largest practical unit of mass, practical unit of mass. Let us revise. 1 hectare is how many? 10 power 4 meters square. 1 ton or metric ton 1000 kg. 1 quintal 100 kg. 1 slug 14.57 kg. 1 pound 0.436 kg. 4536 kg. Chandrasekhar limit 1.4 times of mass of the sun. And remember, CSL is the largest practical unit of mass. Clear? Now what is atomic mass unit? Next is atomic mass unit. It is defined as 1/12th mass of 112C6 atom. 1 atomic mass unit, remember, also known as 1 AMU, that is 1.66 into 10 power minus 27 kg. 1.66 into 10 power minus 27 kg, that is 1 atomic mass unit. The 1 AMU you will able to heard when you will heard the mass of proton and neutron. The mass of proton, of a proton or a neutron, is of the order of 1 AMU. Clear? Next, practical units for measuring time. Practical units for measuring time. The very first, that is solar day. Solar day. It is time taken by the earth to complete one rotation, about its own axis with respect to sun. The time taken by earth to complete one rotation about its own axis with sun. Remember, here there are two terms, revolution and rotation. Revolution means to revolve around something, keeping it at the center or keeping it at the center, you can say the center of the motion. That is revolution, to revolve something, to revolve around something. When rotation is to revolve around its own axis. Earth revolve as well as rotate, both. Revolve means it revolves around the sun and it rotates on its own axis. So it is the time taken by the earth to complete one rotation about its own axis, keeping in respect with sun. This is known as one solar day. Clear? Second is sidereal day. It is the time taken by the earth. It is the time taken by the earth to complete one rotation about its own axis. Here it was with respect to sun, here with respect to distant star. If the star is situated at very far, keeping into mind that star, the time taken to complete one rotation about its own axis is known as sidereal day. Third is solar year. It is the time taken by the earth. It is the time taken by the earth to complete one revolution around sun in its orbit one solar year, that is equal to 365.25 average solar days. Also remember 366.25 sidereal days. 365.25 average solar days. I said only 4 years average in 365 plus 366. You are going to get how much? 365.25 and 366.25 you have to take. Clear? As sidereal days. Moving ahead to the next, that is tropical year. Tropical year, the year in which there is total solar eclipse. Total solar eclipse is called tropical year. Everybody knows solar eclipse and lunar eclipse. Solar eclipse Surya Grahan, lunar eclipse Chandra Grahan. Next, leap year. Next is leap year. Everybody knows what is leap year. The year which is divisible by 4. The year which is divisible by 4 and in which the month of February has 29 days is called a leap year. Next is lunar month. Now what is lunar month? It is the time taken by the moon. It is the time taken by the moon to complete one revolution around the earth in its orbit. Everybody knows one lunar month. How many days? One lunar month, 27.3 days. One lunar month, how many days? 27.3 days. Next is shake. It is the smallest unit. It is the smallest unit of time. Remember, one shake, that is equal to 10 power minus 6 minus 8 seconds. 10 power minus 8 seconds. Shake is 10 power minus 8 seconds, not minus 6, minus 8 seconds. Clear? Practical units for pressure. Practical units for measuring pressure. First is 1 bar, or you can say 1 atmospheric pressure, that is equal to 10 power 5 Newton per meter square, or 10 power 5 Pascal, you may say. Remember, Newton per meter square is same as that of what? Pascal. 1 millibar, that is equal to 10 power 2 Pascal, or you can say 10 power 2 Newton per meter square. Next is 1 torr, that is 1 mm of mercury column. Hg is always mercury. 1 mm of mercury column. 1 atmospheric pressure. 1 atmospheric pressure, that is also known as 1 bar. 760 mm of Hg column. 760 mm of Hg column, also known as 760 torr. Remember, it is 760 torr, 1 atmospheric pressure, or 760 mm Hg of column. As you have already studied that 1 torr is 1 mm Hg of column, therefore 760 mm of Hg of column, that will give you 760 torr. Clear? The next topic is order of magnitude. Next topic is order of magnitude. Now, what is order of magnitude? The order of magnitude, listen carefully. The order of magnitude of a physical quantity is that power of 10 which is closest to its magnitude. The power of 10 which is nearer to its magnitude, that power of 10 is known as what? Order of magnitude. It gives an idea about how big or how small a given physical quantity is. Example, if 10 power is positive, then it is very big. If 10 power is negative, then it is very small. To determine, label to clear from the questions, to determine the order of magnitude of a number capital N, we first express it as n is equal to small n 10 power x. Any physical quantity capital N, that is expressed as small n into 10 power x, where this small n has some conditions. 0.5, this small n must be greater than 0.5, must be less than or equal to 5. This n must be greater than 0.5 and must be less than or equal to 5. Then this x is order of magnitude of n, order of magnitude of capital N. Then you can write, then x will be the order of magnitude of capital N. Now let us take some examples for the same in order to clear what exactly order of a magnitude means. I can give you one example, that is 8. Now this number 8 is greater than 5. We have to convert this 8 in such that it should be greater than 0.5 and it should be less than or equal to 5. Can I shift one position over this on the left hand side? So I can write this 0.8. I have shifted one position to the left, So I have to put 10 power 1 over here. It's going to be plus because I have shifted one position. Left side, right or not? Left position. So we have shifted one position to the left, so I'll put 10 plus 1. 0.8. Check 0.8 is satisfying the condition. Your n should be greater than 0.5. Is it greater than 0.5? Yes. It is less than or equal to 5? Yes. So this 1 stands for what? Order of magnitude. This 1 stands for what? Order of magnitude. So if somebody asks order of magnitude for 8, and you can write order of magnitude. Order of magnitude, that is equal to what? 1. It is equal to 1. Now let us take few more examples and get more clear. Now it is 8. I have to shift one position, that is I can express as 0.8 into 10 power 1. So 10 power is considered to be order of magnitude, so here it would be 1. Till this clear? Next is 49. 49. Sir, if I'll shift one position, it will be 4.9. 4.9 is greater than 0.5, but it is less than or equal to 5. Yes or no? Yes, 4.9 is what? Greater than 0.5. Agree. It is less than or equal to 5 also. Yes. So I can do this. I am shifting one position over here. So again I put 10 power 1. So order of magnitude is what? 1. Now 52. 52, if I'll shift one position, it will be 5.2. 5.2 is greater than 0.5. Agree. But it is not less than equal to 5. Extreme condition is not being satisfied. One of the extreme condition is not being satisfied. It is greater than 0.5. Agree. But it is greater, it is not less than or equal to 5. It is more than 5. So you have to shift again one more position. So it will be 0.52. Again check, 0.52 is greater than 0.5. Yes. It is less than or equal to 5. Yes. So you have to shift two position over here in order to satisfy the condition. So 0.52, I have shifted two position on left. So it will be power will be 2. So order of magnitude is what? 2. Till this clear? Now 55.5, 555 is given. If I'll shift one position, it will be 55.5. It will not satisfy the extreme condition less than or equal to 5. I have to step one more. 5.55, again it is not satisfied. So I have to move again one more, that is 0.555. So 0.555, how many position I have shifted on left? That is 3. So that is 10 power 3. So order of magnitude is what? 3. Clear? Similarly 999. First will not allow, second will not allow, third will not satisfy the condition. So 0.099 into 10 power 3. Order of magnitude is what? 3. 1001. Check. If I'll put 100, not possible. 10, not possible. 1, possible. Yes or no? 1 will be possible. Yes. 1.001 is greater than 0.5, is less than or equal to 5. Condition is satisfied. So I can put 1.001 into 10 power. How many position I have shifted? 3. So my order of magnitude is what? 3. Now I am having a number 753,000. 753,000. What I have to check again? If I'll put 7, I'll shift one position, it will be 75300. It's not going to satisfy. Again 0, 7530. Again not. So I have to keep on shifting. I can 0. I have to go move 1, 2, 3, 4, 5, 6. 0.753000. Clear? So what I am going to put 10 power. How many position I have shifted? 1, 2, 3, 4, 5, 6. So 10 power 6. Order of magnitude is what? 6. 0.135 is satisfying itself. Yes or no? 0.1. Now check. 0.135 is given. Is it greater than 0.5? No. Your condition gets violated. It is less than 0.5. So what to do? Shift 1 this side. So 0.135. I'll shift 1 this side. So it will be 1.35. It's greater than 0.5. Agree. It is less than or equal to 5. Agree. Both the conditions are satisfied. None of the condition is being violated. So I can move this side 1. So that is 1.35 into 10 power. This side means I am moving towards the right. Right means I have to put minus 1 position. So minus 1. Clear? So my order is what? Minus 1. 0.05. 0.05 is not greater than 0.5. Yes or no? So I have to shift position 0.5. See, 0.05 is given. I am shifting one position. It will be 0.5 greater than 0.5. See, there is no equal to sign over here. So it's violates. So I have to again move 1. That is 5. Yes, phi is greater than 0.5 and phi is less than or equal to phi. Equal to condition is given, so this phi will be allowed. So I have to move 2 position over here. That is phi into 10 power. 2 means how much? Minus 2. My order of the magnitude would be what? Minus 2. 0.99. 0.99, you have to think about it. 0.99 is greater than 0.5. Yes. 0.99 is less than or equal to 5. Yes, it is same. So 0.99, there is no need of to shift here and there. So 10 power is 0. So order of magnitude how much? 0. 667, I have to shift how much positions? 0.667. 10 power minus 3. My order of magnitude is what? Minus 3 or plus 3. You are moving towards left, means you have to take what? Plus 3. So my order of magnitude is what? Plus 3. Please don't make mistake over here. Moving towards left you have to consider to be plus, moving towards right you have to consider to be minus. 6.27. It will not possible. I have to shift one position. 0.267 into 10 power minus 1. Order of magnitude is what? Minus 1? No, I am giving you are moving towards left, so you have to take plus 1. So our answer is what? Plus 1. Many of the students make mistake to putting minus over here. Clear? Moving towards left means you have to put plus only. You have to put plus only. 8.87 is not going towards 0.887. 8887. Triple times 8 are there. Again I am moving towards one position left, so it will be 10 power 1. So my order of magnitude is what? Plus 1. Hope it is clear what I mean to say in the case of order and magnitude. I have given so many examples to get clear. Clear? Now moving to the next topic.